Hey guys, so you're watching a video today because I actually have a meeting about our class, so that's why you're watching this video instead of like live-ish, as most we could get to. So just need to watch the video and practice as we go along. So take a pen and paper out and just pretty much do what I do, and we're gonna practice some things, okay? So hopefully you enjoy, and here is a intro to a video I made. Have fun.
People, let me tell you about my best friend. He's a warm-hearted person who loved me till the end. People, let me tell you about my best friend. He's a one-boy, cuddly toy, my up, my down, my pride and joy. People, let me tell you about him. He's so much fun. Whether we're talking man to man or whether we're talking son to son, 'cause he's my best friend. Yeah, he's my best friend.
Today we're going to talk about numbers because that's all we've been doing is, you know, measuring units and all that. But if you notice on the last assignment, like the last three ones, we had really big numbers to write. So for example, if I wanted you to write out a quadrillion, this is what we're going to have to do. A quadrillion has like 6 sets of 3 zeros. So it's going to be 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. How many is that? So 1, 2, 3, 4, 5, 6. So that's gonna be a decimal. So it's so big that it went from here to there. So if we ever have to deal with big numbers, like a quadrillion, a million, or whatever, we gotta write them out. But kind of like you guys, I'm a little lazy. So do you think that there's another way to write all those zeros, or to write a big number like a quadrillion instead of writing it out and counting how many zeros you need? Because there is, and it's called scientific notation. This 1.0 times 10 to the power of 15. So this is what we call scientific notation. And the reason why this is a lot easier and lazier is because this is exactly what a quadrillion is, but written in shorthand. So we don't have to write down all those zeros. So let me explain really quick how we got from here to all those zeros. The way to make a standard notation into scientific notation, the easiest way for me to do it, or for me to explain to you do it right now without getting like all mathematically technical, is all you need to do is count how many spaces to the place you want to get to the decimal, so to make it a smaller number. So for example, you see how I put 1.0 times 10 to the positive 15? It's because you just gotta count how many places to the left, positive, you move the decimal. So this is like the easy, cheaty, kind of a little longer way to do it. So here we go. We're gonna do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if we move the decimal that was right here, this was the decimal, 15 places to the left right here, it's gonna give us 1.0 with a whole bunch of zeros, but you can just leave it like that. And then all you do to notate that you moved it that many places over is by doing times 10 to the 15. So we moved it decimal 15 places to the left, which was a positive 15 move. So that's all we really pretty much did. So for those of you who want to try to count out every step of the way, you can do that too. That's perfectly fine. But there's a little bit easier way to do it. But what you need to do is you have to understand what it means when we say 10 to the power of 15, or 10 to the power of 5, or 10 to the power of 1. And let me explain to you really quick. So the way we're able to do that is because we put the 1.0 times 10 to the whatever power. So to understand what it means for like 10 to the whatever power, we have to break it down mathematically. So right here we have 10. 10 is equivalent to 10 to the power of 1. So that just means it's 10 by itself. But when you want to do it to like 100 equals 10 to the power of 2, or 10 squared. So what that essentially means is you're just multiplying 10 by itself. So 10 times 10, because 10 times 10 equals 100. Same thing when we do 1,000. It's just you're doing 10 multiplied by itself 3 times, which is 10 times 10 times 10, which is 1,000. And then same thing when you do 10,000. It's going to be 10 to the power of 4, which is 10 times 10 times 10 times 10. 10 multiplied by itself 4 times. So keep on doing that, etc., etc. So those are like how you get those like big, large numbers abbreviated in such a small thing. And then, as we know, if you like add a 1 in front of anything, so if you can do like 1.0 times 3, that's 3. So the same concept when you do 10. So 1. I can't even see that, so let me erase that really quick. So when you have 1 times 10, essentially you're just saying that 1 times 10 is 10. So whenever you multiply 1 by if you multiply a number by 1, you're just saying it's just that number, because 1 is just 1. It's just, that's how, I don't know how to explain it even more. Just mathematically, this is going to equal 10. So whatever multiplied by 1 is always going to be itself. So that's how, when we abbreviate things in scientific notation, you can make a big number like what we just said, a quadrillion. You could just do 1.0 times 10 to the 15th, because that's how many times a quadrillion is. It's 10 times itself by 15. So let's just do some other practice problems too. So let's practice together. So do this along with me. So we have, this is going to be hundreds, that's thousands, that's millions. So we have 198 million in standard notation. So let's make this into scientific notation, shorthand. So if you need to, because I do this to this day still to figure out what to the power to put it to. I still count to this day, which is fine, how many places I need to go to make this to a small number to write down. So I want to make it into the smallest number I can. So I'm going to move it so we only have like a 1 point whatever. So let's move it 1, 2, 3, 4, 5, 6, 7, 8. So we're going to move the decimal 8 spaces to the left. So that's going to give us this new number now. It's going to be 1.98 times 10. We said it was 8 spaces to the 8. So to the 10 to the power of 8 is because we moved it 8 spots to the right. And then if you're curious about, because this is the decimal, so you're going to always move the decimal. The decimal is like that placeholder to give us the value. So we went from basically 198 million to 1.98. That's just 1.98. And then we're going to multiply that by 10 to the power of 8, which is just 10 times 10, or 8 times, which gives us 198 million. It doesn't matter what's on the right over here if they're just zeros, but if it's going to be another number, that's a different story. But right now, if it's anything like this, it's fine just to count how many spots you have to move the decimal to figure out what to make it to the power of. So for instance, if I wanted to make it a little bigger, if I wanted to leave it as 19.8, which is fine. Don't know why you do that, but it's fine. You would just essentially just move the decimal place only 7 spots. So instead of 8, it would be 7. So that's how that works. So if you want to move from scientific notation to standard notation, it's kind of the same process. So what I would do is I would freshly write it on the bottom. And then, because we know it's a positive number, it's going to be a big number. So we move this 5 places to the right. So 1, 2, 3, 4, 5, and that's where the decimal is going to be now. And you fill in the blanks with zeros. So it would be 0 there and a 0 here. And if you want to put a 0 on the other side of the decimal place, that's going to be fine. So our new number is going to be, it's going to be 302,600. So that's going to be our new number in standard notation. So again, all I did was I wrote this freshly down here so I could move the decimal and see how many spots or how many zeros I need. So that's how we went from scientific notation to standard notation when we're talking about big numbers. But remember, you could also have a big number that's big, but you could also have a large number that actually means a small number. So we're gonna do that next. So right here we have a big small number. It's small because it's like less than 1, so it's technically a small number, but it's still a lot to write out. We could also make this into shorthand. So from standard notation to scientific notation, the same concept applies. We have our decimal point right here, but instead of going to the left to figure out how many spots it is, we're going to the right. So 1, 2, 3, 4, 5, right there. So it's gonna be 3.254 times 10. And what we said, 5, 1, 2, 3, 4, 5. Yeah, it's 5. But instead of being a positive, it's gonna be a negative 5. Because we know that means that when we want to go from standard to, from scientific to standard, you're gonna move it to the left. So when you have a negative exponent right here, a negative integer, that means that this number is actually small. When it's positive, the number is big. The value is big. When it's a negative, it's going to be a small. So that's like a helpful hint or indication, if we're talking about a big number or a small number. So this is how we went from a small value number from standard definition to scientific notation. Now let's do it the opposite way. Let's go from standard or scientific notation to standard notation for a small value number. So right now we have 69.420 times 10 to the negative 5. We know it's a small number because it has a negative 5 right there. So let's do that. So we're gonna write it down on the bottom so we can move our decimal. All right, so we're going to a small number. So we know it's gonna be small, so we have to go to the left, 5 spots. Because negative 5 means small, 5 to the left. So 1, 2, 3, 4, 5. Our decimal's gonna be right there. And you're gonna fill in the blanks with zeros. So 0 there, and a 0 there. So after that, this is gonna be our new number. So this is from scientific notation to standard notation. What I want you guys to do is practice this one. So it's 3.65 times 10 to the negative 3. Practice making this from scientific notation to standard notation. So pause the video and...
A few moments later.
All right, hopefully you did it, because if not, I'm disappointed. You're cheating. I don't like it. You're gonna make me cry. I cry a lot because of you guys. Congrats. Not really. So let's do this. So look, it's a negative number, so I know it's gonna be a small one. So let's write it freshly on the bottom, and we're gonna move it to the left to make it a small number 3 times. 1, 2, 3. Put our decimal there, and then fill in the zeros. So that is our new number, 0.00395. That's our number. If you got that, congrats. If you didn't, it's okay. Just try again and, I don't know, do better. The next one, I want you to practice before I show you how to do it from this scientific notation to standard notation. So 1.2 times 10 to the power of 1. So try this one out.
A few moments later.
So let's do it together. 1.2. All right, so it's gonna be a big positive integer because it's a positive number, but we only move it to the right 1 time. So essentially, it's just gonna be 12. So that's what it is. All right, so that is it. We're gonna be practicing that for the next couple of days, is transitioning from standard to scientific, or it's called converting from standard to scientific and scientific to standard. So you have an assignment, not today, but tomorrow about that. If you want to start on it now and get it done with, because I'm not going to see you, unfortunately, tomorrow either, because that's our asynchronous day, and today was our synchronous, but I have a meeting. Feel free to do it today, since it's still fresh in your mind. If you do it today, then you're done with your homework for tomorrow, and then you have nothing for our class tomorrow. But if you don't want to do it today, that's fine. Do it tomorrow. Either way, it needs to get done before Saturday. So have fun. Have a nice day. Sorry I couldn't see you. Bye, guys.